Okay, so what we have is some really good stuff here. And I think there is, I don't know, how many of you think this is really what happens then? And why does it happen? The pressure's decreasing. Well, how does that make the depth change like this as opposed to this, or, well, it's not going to be that. How is it that the decreasing pressure makes this happen? Okay, well, you want to think about that, but that is what's going to happen, and that's kind of an intuitive idea. Pressure decreases, water flows more slowly, so the depth changes more slowly, right?
Yeah.
And I'm going to give you a conclusion here. The theoretical conclusion, you don't have to understand all this, but you probably, many of you are in a position to understand this. What do you think I mean by dy over dt?
It's the thing that we did earlier that was.
Well, it's just like what we did earlier with, it's a rate of change.
Yeah.
But with a d instead of a delta, right?
The difference in...
Okay, now listen. This is a rate of change, but this is an instantaneous rate of change. When it becomes instantaneous, we replace the delta with the d. Okay? In this case, if you analyze the pressure or analyze this by energy or in any other number of ways, please have your attention on this and don't distract each other. Okay, dy dt is negative k square root of y. Have you seen this before?
Yeah.
There was a problem.
Square root of y.
First problem on the worksheet I handed out on the second day, where you were asked to work this out. And I think many of you did that successfully because I saw some pretty good results there, okay? That make sense? So, if you have this, then, by magic, y is a quadratic function of t. And the magic is the magic of calculus and differential equations. Okay? So, you don't have to know how to get from here to here. At the end of a good calculus course, you can do this. Okay? My grandson just had a good calculus course. And we were eating dinner, and I just wrote this down and asked him to prove this, and he did. At the end of a good calculus course. Okay? So, you can accept it. But we're going to actually test it and prove it. Okay? So we're going to go out and we're going to measure how long it takes the water to fall from here to here to here to here. Okay? And then we're going to throw it into this model using Excel. I'll also show you how to get it from Wolfram Alpha. Okay? If you put this into Wolfram Alpha, here's how you would do it. You don't have to remember this because you won't necessarily know what it means. You just write y prime equals negative k square root of y. Y of 0 equals 50. and hit the enter key, and it's going to solve it for you and give you that quadratic. Okay? And by the time you reach the end of a good calculus course, you'd be able to fill in all the blanks of this and understand completely what's going on. Okay? And this type of equation and this type of reasoning is not confined to water flowing out of a cylinder. You can apply this in business, economics, finance. Okay, you can apply it very specifically to pressure in the cardiovascular system. Okay, and all over the place in engineering and science. Okay, so very important stuff. Now, with that background, we're going to go out and we're going to take some measurements, and then we're going to set up, please, we're going to set up simultaneous equations. And we're going to maybe solve them by hand, but maybe because of time constraints, we'll go over and use Wolfram Alpha using the matrix methods. Does that make sense? Are you psyched?
Yeah.
Always.
Are you stoked?
Yeah.
Are you looking forward to it?
Sure.
Yeah, it's the 4th day of the week. Well, you know, you all are doing pretty well with that. Okay, so let's do it.